Today I'm going to be telling you how to insert, delete, and search inside of a linked list. But first, before we do that, I want to explain what's so important about a linked list. Why should you use a linked list over some other data sorting methods like an array, for example? Well, you would use a linked list in the case that you didn't know exactly how big your data entry is going to be, or if that data entry would be fluctuating in some sort. So in an array, for example, if we compare the two, an array and a linked list, in an array, you would know exactly how many entries you would have. So I know my array would be the size 10,000. And that would be a good case to use for an array. But in this case, for a linked list, you could use that. But a linked list is for the case that you don't know exactly how big, or you know how big, but it's going to get bigger, but you're not sure how much bigger that size will be. So a linked list is helpful for if you are unsure of the size, and then you don't want to store or use up a bunch of empty, unused space in your memory, taking up just random space that you can use for other things. To not use an unnecessary amount of data that's just empty and wasted. It won't just section off a certain amount and then half of it not be used. If, let's say, you use an array in the case that you should have used a linked list, and let's say you fill up half of the amount of storage, the array takes out that 10,000 units or 10,000 sections, but if you only fill up 5,000, there's 5,000 other sections that you aren't using as just empty and wasting space, and it could be used for other things. In the case of a linked list, it will only save those 5,000 units or 5,000 memory points and won't use any more or any less. So that would be one good case. Or if you have a set of data that's changing and going up and down, you can delete and get rid of and add as many as you want, because it'll add, and if you go over that 10,000 that you think, if you do 10,001, it's not going to have a out of bounds error. It will just keep on adding and adding and adding. It will have no problem. Now I'll tell you how to insert inside of a linked list. But first, what you have to do is you have to have some kind of data, some kind of numbers you're going to insert into this linked list. So for me, let's start off over here. I'll set up the, let's say six numbers we'll put in. Let's say it's 5, 10, 12, 2, and 9. So those would be our 5 data points that we'll want to enter. So we'll start off with 5. First, you want to input the number, in this case the integer of 5. And then in the linked list, they have a thing that has a link at the end of it, and this will point to the next node in your linked list. In this case, our next node would be 10, but at the moment, there is no next node, so it's the only node we have. So that node will point to a null pointer. Null pointer. That null pointer pretty much is the end, and once it gets to a null pointer in code, it will return or error out and say, you've reached the end, we don't know where to go, so that's the end point. And in this case, because you only have one, this will be your head, and the head of a linked list is the beginning, the first entry of your linked list. And that is where you'll always start in the linked list by looking at. You will always start at the head and then traverse your way through the linked list. And since there's also only one, it is the beginning and the end, so it is also the tail. Tail meaning the end, last entry point. So right now we have 1, we inserted it, it points to the null pointer. Now we'll bring in the 10. Let's use the 5 again as the section for the pointer to the next node. It points to 10, because 10 is the end, that is the tail, and this is the head, this is the beginning, and then that points, because there's nothing left, points to the null pointer. And then if you wanted to, let's say for the next one, 12, instead of pointing it at the end, connecting it straight into it, let's say you wanted to point it at the beginning, at the head. So you would start with 5, point that to the 10, as you would. Oops. And that still points to a null pointer, but instead now you're putting in 12. 12, and 12 will then, because you're saying pointing to it, you'll point it to 5, which was the head. And then 12 will become the new head, so 5 is no longer head, 12 is the head because of the first one. And then 10 is still the tail, because it is the end. So then, what you'll do for now, since you have the new 12, 5, 10, that is the order, what we should have done before is when you add it, you always start the head like I said before. So in this case, you would start the head, and then you would insert the 12, and the 12 would point to the head, and then you would make a new head equals 12. Now let's insert it between 5 and 10, the next one, 2. So you start the head, you have 12, that head points to 5, that 5, since we'll insert it between them, we get the new node down here, and pointer part, and then 5 will now point to 12, point to 2, which is the new entry, point to 2, and then the 2 will then point to 10, it will now be inserted. And then 10, because it's the end, will point to null. And that tail. And when we start, we still have one more left. Let's say we insert it in between 12 and 5. So then 12, always start the head. So 12, head. And then make this, point it to the new one, which would be down here. We'll put it down here just so you know it's new, which is 9. Comes down, below, 9. And then 9 will then point to the next one, which is 12, points the new, back to 5. And 5 points to 2. I can write out like that. 5 points to 2. 2 points to 10. And then 10 points to null. And now we have inserted all of the nodes into our linked list that we have right now. Next, I'll go over searching. And so with the search inside of a linked list, it's pretty simple. All you have to do is start the head, like everything. You always start the head for inserting, deleting, and searching, because that's the first point you start at. So at the head, let's say we wanted to search for 12. Oh, that's the head. Let's say we go after 10. So in 10, we'd look at the first one. It's 12. Is 12 equal to what we want? It's 10? Nope. Move to the next one. It's pointing to 9. Is 9 10? Nope, it's not. Go to the next one. It's pointing to 9 points to 5, so we move to 5. Is 5 10? Nope. 5 points to what? 2. Is it 10? Nope. 2 points to 10. Oh, we found 10. There's our answer. And then let's say we're looking for 8. 8 doesn't belong, but let's see if, just to go over what it would do. Start the head, which is 12. 12 is not 8, so we search for 8. Search for 8. 8, is 12 equal to 8? Nope. Okay, where does 12 point to? 12 points to 9. Is 9 8? No, it's not. Where does 9 point to? 9 points to 5. Is 5 8? Nope. 5 points to 2. Is 2 8? Nope. 2 points to 10. Is 10 8? No, it's not. 10 points to null. So since it's pointing to null, you know it's at the end. So then that means null. So that means null, meaning search 8 does not exist. So you would return saying 8 is not in this linked list that we have right here. So then you just return some way in your code, whatever it is. Say 8 does not exist. Please type in a new number to search for. And then you would look through it and try and find whichever you want. It's pretty simple to search. You just go start the head, and then you follow how it's linked through, and you figure it out. Okay, so now we will be deleting our linked list. Not the entire linked list, but one of the nodes inside of our linked list. I'll redraw it over here. So it starts off, so it's a little bit more neat. Starts off with 12 as the head. 12 points to 9. 9 points to 5. 5 points to 2. 2 points to 10. Hopefully that's 10. And then 10 points to null. Is at the end. So now for whenever we want to delete, don't forget this is the head. This is the tail. Tail isn't as important as the head, because the head typically is where you start. Tail, of course, is the end. Once you get to the tail, you're always done. Let's delete 5. Delete 5. So we're going to try and delete the node of 5. So what we have to do is we have to get something called the temporary node, which would be equal to the head node. It's called temp. And what we want to do is go one before whatever node we're trying to delete for the temporary node. In this case, it is 5. So we want to push this node down and always check one ahead of it. So we say temp is equal to head, head is then equal to the next one. So we move it over one, I'll move it over by just drawing a line. Move it over, and then we look at the next one. Is the next one equal to what we want to delete, which is 5? Yes. So then temp is where it wants to be. And then we add a new node called the delete node, or the D node is what I'm going to put it as. And then that D node is equal to the rest of it points to the rest of the nodes down the list. And so what we want to do is say delete D node. Before you delete, what you want to do is set the temp node equal to the D node's next. So in that, all it means is what we want to do is point this end of temp, which is equal to 9, pointing that 9 equal to 2. So we want to go around and go to where the 2 is supposed to be. And then all you have to do is delete this node, and then you're done. And then now what you have is 12 pointing to 9, points to 2, points to 10, points to null. Let me go over it again. The simple way to do it, which I'll include in the beginning, is you just try to delete whichever one it is. In this case, we were trying to delete 5. So you just want whatever it is before it to point to whatever it is after it. So in our case, we want 9 to point to 2. So we want 9 to go over 5 and point just straight to 2, and then delete this. But how we do that is we need a temp node and a delete node. This temp node follows through beforehand to go one before whatever node we're trying to delete. So it always looks ahead one. So this temp node starts at head, it goes to 9, and then it looks ahead one before it moves again. Well, first it starts ahead, looks ahead, is 9 what we want to delete? Nope. So we move ahead one, and it looks at 5. Is 5 what we want to delete? Yes. Insert a new node called the D node, the delete node. That delete node is equated to the 5, and then we say our temp node. We set the temp node equal to the next node of pointing to, which is 2. So we go around it, and then everything is set, and then you delete the D node, which is equal to 5. So in theory, you're pretty much deleting 5 and the D node at the same time. And then since temp is equal to 9, which is also equal to 12, temp points to temp, and then we're circumventing the D node to point to 2. In this case, getting our new linked list, which goes 12, 9, 2, 10, null. A little sloppy, but you can do. Let's delete another one. Let's do a slightly easier one of deleting 12, the head. Head, new node. So delete 12. Delete 12. So when we delete the head node, that's pretty easy. All you have to do is turn the one next to it that is pointing into the head. So then we say this is no longer the head. This one is the head. And then use delete 12. And now the new head node is 9, and that is our new linked list. And it goes the same way for when you would delete the last node of 10. So if in the new node we wanted to delete 10, all you have to do is start at the head, look ahead. Is 2 what we want to delete? Nope. Move up one. Is 10 what we want to delete? Yes. 2 points to null now. Instead of pointing it to 10, you just point it down to null. And then delete, well, I say circumnavigate to null, and then you delete 10, and you're done. And that's how you essentially delete